Okay, so this is the lesson for Tuesday, the 19th. We're getting into our unit on rational functions, and we know rational can be written as a fraction, so that's what we're going to be looking at, functions that are written as fractions. And so the little opening lesson for us here today introduces three different types of variation. We have direct variation, inverse variation, and joint variation. That's called our constant of variation, and that will always be a number value. So if we are a direct variation, we are y equals some number times x. If we are an inverse variation, we are y equals some number divided by x. When we have a joint variation, that just means we have more than one thing happening. So it could be a double multiplication happening, it could be a direct and an inverse happening, but it'll be y equals some number, could be times an x and times a z, so more than one thing happening on a joint variation. Okay, so the first thing we're going to look at is how to figure out what type of variation we're dealing with. So, let me get us a clean piece of paper here. I'm going to give us three different functions. This first one says xy equals 7. Second one says y equals x plus 3. And the third one says y over 4 equals x. Okay, and so what we're going to do with each of these functions is we're going to tell what kind it is and then figure out what the constant is. So to determine what kind of function it is, what you saw from our leading screen was we had a variable isolated. Most of the time it's going to be y. On a joint variation it could be a different variable, but most of the time it'll be your y that's isolated. So we want to go ahead up there on that first one where it says xy equals 7, and we want to solve that for y. So to solve that for y, we would divide both sides by x. So we would have y equals 7 divided by x. Now we're trying to determine if this is a variation at all, and if so, what type it is. This is the spitting image here of y equals a over x, which is an inverse variation. And our a in this case, our constant of variation, will be 7. So number one would be an inverse variation, and the constant of variation will be 7. So to determine that, we had to take what they gave us, and we had to solve it for y and figure our inverse variation, our constant of variation. Okay, on the second one, right here, y equals x plus 3, it's already solved for y, so there's nothing to do on that. But this is going to not be a variation at all. So on this one we could say it's neither direct or inverse or joint for that matter. And it's all because of this addition sign. If you noticed on our first page where I introduced you to the types of variations, there was multiplication happening and there was division happening. We didn't see any of this addition or any subtraction. So this is just a linear function, which is good. We can graph that lickety split, but it's neither variation. Okay? Alright, so number 3 down here, I got y divided by 4 equals x. So like it is, some people will be tempted just to immediately say, oh, it's inverse because it's division. Well, not so fast there, Speedy. Remember, we need to get the y by itself. So my y is being divided by 4. What undoes that is a multiplication of 4. So you're going to multiply both sides by 4, which would give you y equals 4x. Now you can clearly see this looks just like y equals ax, which is a direct variation. And so our constant, our a, is 4. So that's our constant of variation. Okay? Alright, so we can identify different types. Now we're actually going to write an inverse variation. So what we're told here, and this is how some of these problems will read, it says the variables x and y vary inversely. So as soon as I read that on an assignment or a test or whatever, it says the variables x and y vary inversely, I'm going to stop and write down my model for an inverse variation. Okay, so there it is, y equals a to the x. Why did I write that? Because the problem said inversely. Okay, inversely. So let me go back and read again for you. It says the variables x and y vary inversely. Y equals 7 when x equals 4. So we want to find an equation, and for y, find y, so we don't know y, when x equals 2. Okay? So they're telling us that we've got this function that varies inversely, and we can get this ordered pair when y is 7, x is 4. So we want to be able to use this information to figure out what y would be when x is 2. So if we look over here, we got y's and x's, y and x, y and x, y and x's, but what we don't have is a. So you're going to use your first piece of it, your first piece of information and plug that in to solve for a. Then you can take your a down here to where you're missing information and figure out what the problem's asking for, figure out your y. So we're going to plug 7 in for the y and 4 in for the x to solve for our constant of variation. So we'll say 7 equals a divided by 4. Okay, now a is being divided by 4, so to undo that and solve for a, you just multiply by 4. So you now know your constant of variation is 28. So this second piece of info here, this is where we're going to get our final answer from. We'll say y, because we don't know that, equals a, which we now know is 28 divided by 2, because they told us x is 2. So in this inverse variation, when x equals 2, y has to be 28 divided by 2, which means our y is 14. Okay? All right. Okay, so let's look at something that varies jointly now. So this says the variable z varies jointly with x and y. Now that's worded a little bit different. The last problem that we did inversely, it said y varies inversely, so I wrote y first. So that's how you're always going to start your problem. This one says z varies jointly, so it's going to be z equals, and then it said z varies jointly with x and y. So I'll have my constant, my x, and my y. Okay? So it says z is negative 75 when x is 3 and y is negative 5. Make my 3 look a little prettier. So it wants us to use that info to find z. So I don't know my z. When x is 2 and y is 6. So our job here is going to be the same as it was on the last problem. We got to take this piece where we know everything and use that to solve for your constant. Then once we get a constant, we can come down here to our missing info and solve for what we need. Okay? So we're going to say z, which is negative 75, equals a times x, which is 3, times y, which is negative 5. Okay? So there you got 3 times negative 5, so you know that's negative 15. So you got negative 75 is equal to, you could write a times negative 15, that's fine if you want to write it that way. I usually write the number before the variable because it's the coefficient, so I'm going to write negative 15a. So then to finish that off, to solve for a, you're just dividing, and we know negative divided by negative is going to give us a positive. And 75 divided by 15 gives us an a of 5. Okay? So now we can take that a, 5, plug it in here, and then plug in that x and y and be able to solve this for z, which is what we're looking for. So z equals a, which is 5, times, I'm in this new info now, x is 2 and y is 6. So z equals 5 times 2 is 10, times 6 is 60. So that'll be your final answer on that. Bada bing, bada boom. Okay, so that's it for today's stuff. Tomorrow you're going to have an assignment over variation, and it's going to be pretty simple. It's not even going to get into the joint, which is the last thing we did there. It's just going to be mostly inverse. There'll be 1 or 2 direct on there, but it's mostly going to be inverse. So you can, tomorrow as you're working on the assignment, you can come back and reference this video again if you need to, but that'll be it for today, so be ready for your assignment tomorrow.